The King John's Visitor Centre is a horizontally stable structure, which is important as, being an island, it is frequently subjected to wind force. This wind can hit the building from the side, in line with the wall truss, or head on, towards the glass window. Forces coming from these two perpendicular directions needed to be accounted for by engineers working on the project in order to ensure structural stability. When wind is applied along the length, the structure is put under horizontal load. To deal with this load, large foundations could be used, but the engineers couldn't do this for the visitor centre project because of the archaeology of the site. Hence they decided to design a portal frame. This design incorporates two connections formed by 4 pins. With each connection, its 2 pins, separated by a distance, create a moment, as one pushes and one pulls. This moment creates resistance, and this resistance prevents the structure from moving horizontally. The following video displays the rigidity of the structure. As shown, the structure does not move under the horizontal load applied by Gavin and Aidan. In fact, the structure only moves when buckling occurs, but in real life, there are 3 floors in the building which prevent this buckling effect. This is why, during our visit to the castle, the structure wasn't moving around. When wind is applied towards the glass windows, the structure is once again subjected to horizontal load. As wind strikes the window frame, the glass bends and deflects. The force of the wind is then transferred from the glass to the aluminium frame, and from the frame to the floor diaphragm. Each floor diaphragm is connected at 4 corners to the wall truss. The wall truss is connected to the portal frame, which is connected to the foundations. Hence, the wind load in this direction is dealt with through load transferring. Shown here is the horizontal load path for scenario 1, when wind hits the portal frame. The moments create equilibrium. And shown here is the horizontal load path for scenario 2, when wind strikes the visitor centre head on. The joints connecting the steps in the path are crucial, hence our decision to discuss 2 such connections as our 2 key points. Generally, in construction, transportation of materials is required, thus parts need to be connected on site. The primary floor beam needed to be connected to the wall truss in order to transfer load from the inside of the building to the outside. Rather unusually, particularly for the time, the structure of the visitor centre was designed to be seen on the outside, similar to the Pompidou in Paris. This meant that connecting the primary beam to the structural element would be difficult. Leakage needed to be avoided, with a monthly precipitation of around 100 mils and a horizontal rainfall due to wind. Limerick is a wet county, and so gaps in the connection could not be present. The steel plate here is what allows the beam to punch through to the truss without leakage ensuing. The wall truss is connected to the portal frame by 4 pins. A pair of pins forms one connection, one couple, one moment of resistance. With one connection under horizontal load, the portal sways. With 2 connections under horizontal load, the portal is rigid, as we saw in the video earlier. There is also a connection between the portal frame and the truss at the centre floor diaphragm for extra stability. To conclude, the King John's Castle Visitor Centre is an award-winning structure despite controversies over its appearance when it was first constructed. It blends functionality with aesthetic and enriches the visiting experience of the castle. Its modern look may contrast the medieval castle, but it does not ignore the history of the site. It emphasises the importance of its archaeology while also standing as a safe, practical structure. It is one of the greatest engineering achievements of Limerick City. Thank you for listening.